Alright guys, in this trek into DIY tech, we're going to continue with our ZD550 drone build. So we're going to go ahead and put the motors on here. We'll put the ESCs and we'll maybe add the flight controller in there, and we'll see how everything gets connected on there. I'm thinking that we're going to use the middle section for everything power, and we'll put everything control on the top. So here we go. Let's get to it. All right, so as we start, what we're going to do is, in order to get this flat on the table, I'm going to go ahead and take the battery section out. We've got a new one for this, so we'll probably replace that with the shorter one, as I said in the last video. We're also going to take the landing gear out of here, and that way we'll be able to get it flat on the table and be easier to see what's going on for you guys. So one of the cool things that I've picked up over the years is this ball end Allen wrench. And so as you can see there, see if we can get it to focus at that point there. It's shaped like a ball on the end, as the name would indicate, but you're able to get these in at an angle, so you don't have to go straight down like this. You can get this in at an angle and still ooh, I cranked those down, didn't I? Oh wow, yeah, earthquake. And still, be able to turn these even at an angle. I'm sure most of you have seen these before. I pick up a lot of tools at McMaster, and you can get whole sets like that. I'm sure they have them at Harbor Freight probably, and Home Depot, all those other ones. But it comes in handy especially when you're doing stuff below. As you can see, to get to the other ones, you would be at an angle. So yeah, it's cool in there. So what I'm going to do is I'm going to, like I said, remove the landing gear and the battery holder there, which is also where the camera. We're gonna have our gimbal down here as well. Probably not standard for these quads. They usually have a few pieces of carbon fiber tube coming out this way, and then they attach the camera there. We'll look at some of those pictures and compare later. But yeah, we'll see you on the other end after I take all this off. All right, we've got all the extra stuff off of there right now. One thing that I forgot that we had done in one of the last videos was we added some Loctite to these screws. If you can see right there, that little blue band, as you're supposed to, right? You added Loctite or Threadlocker, right? It was on there. I forgot about that, and that's why the screws were so hard to get out, as they should be with the Loctite on there. But all right, we've got the landing gear. The top plate is off, and the battery carrier is off. I've got these little arrows here so that as I'm adding the other components, I don't obscure the holes where the screws are going to go for the battery carrier. And if you're wondering where these little arrows came from, it's just a strip of masking that never mind. I'll just show you. Here we go. now that you know how to make these little arrows from masking tape, which I'm sure that's a highly marketable skill somewhere. Um, what we're gonna do, and I've marked these. I've got 1, 3, 2, and 4 on there. That's just the way that the way they were on the original, the donor quad that all these parts came from. What I want to do is I want to minimize how much troubleshooting we're doing. So since everything was working the way it was wired up, we're going to wire it up the same exact way. And then if we're going to tweak it, we'll tweak it from there. Right. So big thing that is worrying me. Right. So the original screws will probably not be able to use these original screws, because you see how thick this motor mount is. And it's thick because this is made out of PLA, 3D printed PLA, and you have, layers, even though the layers are going this way and not this way, which gives it more strength, right? So if it's going to delaminate, it's going to open up this way. But still, I made it probably a lot thicker than it needs to be. But which means that these screws are very long. And so what's going to happen, we don't want the screws. So you can see in there, just barely, you'll see better when I get the motors off there. A big concern that you want the screws not to protrude into where the windings are, right? Because obviously you're going to cause damage to your motors. You just want the screws to go in just about that far there, right? So we'll see how that works out. I've got a few bags of hardware, meaning screws and stuff, to replace these screws that are shorter. Hopefully I ordered the right size. But you can see, right, that carbon fiber is stronger. It's kind of thin though. We'll see how that works out. Obviously they've been flying, right? I haven't seen a lot of complaints about these motors ripping out of these frames and just the or maybe I haven't looked in the right place. But yeah, we're gonna get these in here. I have shorter screws. We'll see how that works out. All right, we've got all the motors liberated from their motor mounts. You're like, how did he do that so quick? I cheated. So I've got this ratchet, and it's got this ball end handle on it. It's reversible and everything. I forgot if I remember where I picked this up, I'll put it in the description below. But as my arthritis progresses, this has been a very good tool for me. I keep this around, and it's got the standard bit holder on the end. It's not magnetic, so that's another thing about this guy. It's not magnetic. It's got this spring, and it's there's a ball on this end, spring loaded, and you can almost see in there. It's kind of hard to see, but you can almost see in there where the ball protrudes into that little hex cavity, and it holds it well, and it feels good. Oh, also, if anybody's got any home remedies for arthritis, feel free to put them down in the comments. I will read it. So thank you in advance for that. All right, so we've got all the motors detached. We've transferred the numbers on there, because I know you were thinking, hey, I took the motors off. The numbers were actually on the booms or the arms, and as in some circles we'll use arms. We tend to use booms here at Sprocket to describe the motor or the arms on the quadcopters. I've got a bunch of these little bags that I use for like electronic parts. These are ESDs. You can tell they're the pink color bag. They're ESD bags, but they work really well for keeping these parts together. Since we're trying to preserve the frame that we removed all the parts from for later use, I'm just gonna put the screws in there, and store everything together that way. That way, once we want to rebuild that thing, we'll have everything together. All right, so next thing we're gonna go to is we're gonna try putting one of these motors in there on the new motor mounts and see what kind of issues we have with the screws. As I said, I've got a few bags of hardware that we can try, nylon washers, all of that stuff. We'll get these in there. We're not going to be using any vibration damping on the motors. That long time ago, that was done. It's not done anymore. There's a lot of vibration damping on the flight controllers, and there's even software or firmware based vibration damping these days. No need for any of that. So we're just going to go ahead and grab one of these guys and try to install it on one of the booms. Here we go. All right, so here you're going to notice this is an interesting pattern, right? So we have these slots here, and then we have these closed slots here. So on the KDE motors, a lot of things, right? So, we're going to be going over the edge of this carbon fiber with these cables. We'll see how that works out. It looks like they cut the carbon fiber back to where the edge of the plastic is showing there. So that might mitigate some of the abrasion on these wires. We'll see how that works out. But we're going to go through this hole and down the tube to the other end where the ESC connects here. We'll see how all that goes. We'll install it that way first, and then we'll see how that works out. But the slots there, you can see the hole patterns here. And KDE motors are really cool in that they have provided just about every hole pattern you can encounter for the motor mounts. So they made the motor adapt to the different motor mounts. In this case, we have the motor mount adapting to the different types of motor. So which is cool. Some of these hole patterns are square. Some of these hole patterns, the original hole pattern on the ones that we just removed, were staggered. So meaning the screws were non-concentric. Let me show you. I'll show you what that looks like. Hold on. So you can see there that these are non-concentric. And I'll give you the graphic so you can see. And so these motors were able to adapt to that. The Phantom 4 motors have that hole pattern. Anyway, but different brand motors, sometimes they'll have a square hole pattern, which makes all of these holes concentric, and it'll make a square pattern. But not these. And so it's cool. Those motor mounts are going to work for us. So one of the other things that I wanted to show you is the motor on the left here. So the KDE motor, I'm not sure. I'll check later. I don't think these are available anymore. But this is so it's just a slightly stronger, without getting into details, right? All the math and everything. Same way of getting the props on there and everything. Because we're actually using Phantom 3 props. This was a motor that was used or has been used to directly replace Phantom 3 motors. So this is just a beefier stand-in for that, but you see the hole patterns on there. Anyway, let's get back to the build. All right, so at this point I'm feeling like in order to properly mount these motors in here, we're going to have to remove these motor mounts from here. I know they're probably feeling really comfortable where they are right now, but we'll just loosen this stuff enough to get them out of here. To slide this off. It's just a clamp style situation, kind of like a clamshell. And these are nylon insert nuts, and so we'll just loosen it a little bit and see if we can just slide it off. And that way we're sure to. Oh yeah, that'll work. All right, now we can access the back side of that. We'll see. Looks like that's enough to get the screws through there. Oh yeah, okay, that's awesome. That'll work. So cool thing. I know you guys noticed that there were LEDs on the motor mounts from the booms that I just removed all these motors. We're going to get some. We're going to go to Adafruit. We'll get some light rings or something like that, and we'll make a cool setup here. There's also going to be a Copilot that I had mentioned before. So this is a really cool carrier for an Arduino Nano. We're going to have the Copilot be an Arduino Nano. So we'll set that up on there somehow with some spacers and some screws, so that we can, mess around with different configurations and stuff. But one of the things we're going to have the Arduino Nano do is we're going to have it automatically sense, using some of you may recognize this. This is an ultrasonic sensor. We're going to use this ultrasonic sensor facing down to detect how high off the ground we are, so that even if we pull up the landing gear manually, it will automatically deploy the landing gear before the camera has time to contact the ground. At least that is how it's going to work in theory. We'll see how well that works. So we'll get that in there, and it'll just be on the bottom plate set up like this, right? So we've got plenty of holes and stuff to work with, to where we can set that up. So this frame is starting to grow on me. So we can set this facing down and maybe put a couple screws in there or a mounting plate, something like that, so that we can get the wires through. Obviously this is the top plate, but the bottom plate has similar slots and mounting holes for screws and everything in it. So yeah, we'll see how that goes. But the idea is that this facing down, right, as you're landing, we pick up the distance from the ground, and it automatically deploys the landing gear. We'll see. We've got a lot of stuff to do on there. But again, I keep derailing us. Let's get this motor on there. Yeah, you guessed it. This was going to be hard to do with this all together, so I wound up taking it apart. I hate to do that because the nylocks or the nylon insert nuts, obviously there's only so many times you can tighten those down and unscrew them without the nylon giving up on you. Hopefully this is the only time I'm going to have to do that. But yeah, I decided that this is a pretty important step. So best to just take this apart and go ahead and do it that way. But I did measure, and with that washer on there, so we're gonna go with a metal washer. That's a stainless steel, so that we don't have any oxidation or rusting on there. But we have some M36, well, it's a 3.5 by 6 millimeters long, and that works out really nicely in there. Doesn't contact the coils in any way. So we're gonna get those in there, and again we're gonna use Loctite to put these on there. We'll cut to where I've got all 4 screws in there and the motor situated. I'll show you what that looks like. Won't bore you with putting these back in there. If you look on the other video, you see how I do the Loctite. I just put it in a bottle cap and I dip the screws in there and put them through. But yeah, we'll see you in for you. It'll be just a second when we have this motor in there. All right, here we are. This is the last one getting put together. You can see, all right, so we had to add a couple of nylon washers there. So we got the stainless steel, 2 nylon washers. Those are probably going to be replaced with smaller diameter, outer diameter washers, because you can see how close that is. You can see how close that is to that retainer there. So yeah, that's probably going to get switched out later, but at this point, that is right. It puts the screw at the length that it needs to be. So, all right, let's put the rest of them together. Next thing you're gonna see, all of these will be back on the booms, and we'll go to the frame, install the rest of the components. All right, great. As you can see, we've got them all in there. And this is pretty cool because you can stand it up when all the arms are down. So next step is going to be to put all of the power distribution stuff in here, and the signal distribution stuff as well. So let me lay the thing the way that it was in the previous quad. So I didn't disconnect any of the wires to see if we can keep everything, see how much we can keep of the previous. So it looks like the 4 holes in the middle here where the cooling fan is, in case we had some high power stuff going on. We're not gonna need to use that since the motors and everything else aren't that big, but it looks like the holes match up. You can see there. So that's good. We can use that, and these guys are laid out like this, so we'll probably get them in there like so. I don't know. We'll see how all the wires go in there. It's gonna be a mess anyway. It'll be contained between the two plates anyway. So when we put the top plate back on there, we'll have this going on. So that'll contain all of that in there. Eventually, I want to make some plastic sides that'll go into these little slots and stuff to enclose everything. But yeah, for now, this is what we're gonna try to do. So it does look like we're also going to have, aside from putting those in there, once we start putting everything in here, it's gonna block the holes. It's gonna block the holes for the battery mount. So what I'm gonna do next is I'm gonna go back in there, and remember, we're gonna make the battery mount shorter, right? So we're gonna make the battery mount shorter to get that battery in there. So I've already got shorter ones of these, so we'll bring those out and replace these first. Make that shorter. All right, you can see even with this chunky battery, yeah, it's a little over. So yeah, we're gonna put the shorter ones in there. You see those slots in there? Give us a little wiggle room when we set that up. So we'll put those back in there loosely, and when we attach to the bottom of the quad, we'll tighten them up. But there's another 4 holes here. Those we're going to use to mount the gimbal in there. So yeah, go ahead and zip through this. All right, so we've got them all in there, snugged up, around about where they were before. So once we get these installed from the quad side, then we'll loosen these back up and put some Loctite in there, but we'll leave them as is for now so we can get those in there. And you can see, yeah, a lot better fit. This will give us enough room to get the strap in there still, and also give us enough room for the heads of the screws that are going to stick through the frame that way for mounting all the other hardware that's going to go in there. There's also going to be a pad down here, battery pad down here, to keep this battery from, as Mr. Bardwell says, ejecting the battery, right? So we want to keep that from happening. So we're gonna put a battery pad in here, and then we're gonna probably put double strap that. But yeah, looks pretty good. Yeah, and so this is probably going to be the biggest battery that we have in there. You know, give us a good flight time, a good ratio of flight time to weight there. We'll see. All right, there's that. All right, so what I've decided we're going to go with here is, in order to secure this power distribution board, so we're going to secure that first. So we're going to go ahead and secure that first, and then we'll run the wires everywhere they need to go. So to do that, we're going to use this M3 M310. We're going to use this smaller footprint nylon washer on the bottom. We're going to put the board in there. We're going to put this nylon washer on top, and then we're going to cap that off with another locking washer. So this is a nylon insert locking washer, not washer, a lock nut on top of that, and so that'll secure everything. This one is thick enough to where, so you can see there, it's got a little thickness to it. We're going to use that as a spacer to keep these wires on the back. So I do have the 5 volts tapping from the power distribution board. So forgot what electronics were running with that, but it was we had electronics that we wanted to kick on at the same time that we kick this board on. So that's why I did that. You can see here there's current and voltage on the back of there. That's also broken out on this connector, and that goes back. This connector, this cable is going to go back to the flight controller, so the flight controller will be able to read current and voltage from this board. We'll be able to keep track of that on the flight controller. So yeah, we're going to leave those broken out back here because it's like an extra connector. This is permanently connected there. So I can't remember. I'm sure it'll come to me once we start running all these wires. How it was connected before. It may well have been the Copilot processor that we had plugged in before. But anyway, we'll see. So yeah, we're just gonna go ahead and do that, and we'll meet up on the other side. Ajá.
Ajá, ¿cómo estás?
What you doing?
¿Ah?
¿Qué tú haces?
¿Dónde tú estás? Que no se oye casi.
Ajá, ¿qué tú haces ahí?
Yo no entiendo qué tú dices.
No entiende lo que yo digo.
No,
Oh
porque...
my God.
Espérate.
Oh my
es que
God.
espérate, contra. que
Ajá.
Es que se te oye
Ajá.
como si te hubieras metido en una bolsa, qué sé yo.
¿En una bolsa?
Glog.
Oh, man.
¿A dónde tú estás? ¿En una tienda?
No. Estoy en el laboratorio.
¿Ah?
Estoy en el laboratorio.
¿Qué te pasó?
¿Ah?
¿Qué te pasó?
No, nada, estoy en el laboratorio.
Oh. Bueno.
Estoy trabajando.
Bueno. ¿Y para qué coges y me asusta?
¿Ah?
Si a mí se me desto el corazón por culpa tuya, ¿ves?
¿Por qué?
Por estarme haciendo maldades.
¿Maldades? ¿Por qué?
Sí, hablando así como que si estuviera enfermo.
Estoy en el laboratorio del trabajo, ma.
Bueno. Tú no me habías dicho que tenía laboratorio ni nada de eso.
Sí. Oh, man.
En esta semana llega el paquete, está pendiente.
Ok.
Ajá.
Ok, voy a estar esperando. Voy a estar esperando cuando llegue.
No, para que sepa que vas.
Me voy a quedar en la puerta esperando. Yo sabía que era la novela. ¿Cuál novela es? Oh, wow. All right. So we got this guy bolted down real good. So we found out where the 5 volts is going. 5 volts is going to the logic for the ESCs. So these ESCs have the ability to have external power going to the logic. Not that's aside from the power that goes to the motors, right? So we've got some larger gauge wires that can handle the amperage for the motors here, and the red wire there is going to the 5-volt logic on board, as well as the signal and the signal ground here. So what I had done is, get using the 5 volts from the power distribution board. We were going into the logic for the ESCs as to separate that out from the other onboard stuff that we've got going on. So we've got another BEC here that is sending 5 volts. This is the circuit, I believe, that's going to the Copilot. So we'll see. It's got 2 connectors on there. We'll see how that goes. Or this one. So this one, I believe, is going to or was originally plugged in, if I'm not mistaken, to the gimbal. And so that's a raw power coming from the battery. So we had the battery plugged in directly to the gimbal. We'll see how that changes. We may change that later. So cool thing about these little distribution boards here, we have another one because we're gonna use the chimes. We're gonna use the Pixhawk 4, just so that this is accessible to everybody, right? So Pixhawk 4 is all over the place, or the Pixhawk-like, or Pix clones, are all over the place. So this one just happens to be made by Holy Bro. But you can see here, PWM out is broken out on one. We also have the FMU PWMs broken out. So we have 8 here and 8 here. So we're going to use these for the motors. This is PWM out, FMU PWM. We're going to have the aux channels on. We're going to explore this again when it's been a while, but we'll take a look at that when we get to Q ground control and we start setting this whole thing up. But the idea is that you can run 8 motors on here. So you can do 2 per arm or 1 per arm and have an octo. If you have a quadcopter, you can have a 4-8. But the thing is, we're running the motors from one, and the difference is these are routed differently as they come from the microcontroller that's in here for the flight controller. Again, we're not going to get into too deep into detail on that one because this is the assembly video, but that's why we have so many channels going out. So we can run the motors here, and then landing gear and stuff like that. You can move over to here, gimbal, all of that other stuff. You can put on the aux channels, and all that's configurable through your ground control software. Yeah. So here we go. We're gonna have to unplug all of this so we can route everything. Good thing is everything is numbered, right? So let's go ahead and do that. All right, we're gonna have a go at setting up these or plugging in the motor wires. So I've color coded these, And again, you can switch this around later. So usually when you have motors and you want to change direction physically, right? So you can go into software and change direction a lot of times. But what you do is you switch two of these, and that will change the direction of that the motor is running. So the direction that the motor is turning, and it can be any two, right? So you can switch any two wires as they're connected to the motor, and it will change the direction. But I've done this. I've marked these so I can plug them back in the same way they were in the quad before, because it was running before. So that's one less thing to troubleshoot. So I have just enough space to pull this wire out and plug it in. So being careful not to break the insulation on there. We're getting that plugged in. There's the red one. Oop. This is a lot easier when no one's watching. And here we go. Last wire going in. The cool part is this is as far as these wires are going to be extended, because the arm is folded right now. So this is as far as these cables are going to be stretched. And so there you go. Going to plug in the rest of these, and we'll see you in a bit. All right. Now that we've got all the tie wraps in, we'll cut these back just to get some clarity in here. Cut all these guys back. So everything looks a lot neater now. You can see where the wires are actually going. Normally I have a lot of, when I actually do a CAD design for plates and stuff like that, I put attach points for the tie wraps and stuff. But since this is a one of those DIY frames, what we're going to do is, once we get all of this settled, see, I've tie wrapped these together, but they're not tie wrapped down to the frame yet. So once I get all of this and I'm satisfied where everything's going, I'll put a couple of these down, so that will hold the ESCs in place and they won't be bouncing around. So the thing that I've done here, so you see the heat sinks, I have the heat sinks facing out, right? So we're going to take advantage of the fact that this is an open air frame, and we have the heat sinks facing out, and that'll take advantage of that airflow as we're flying. So I've done that with both of these. This is not going to get hot enough to melt this, so not too worried about that. Just keeping these out of the way. These are, I think I mentioned before, programming cables. There's a little board that plugs into here. It's a USB board and some software, and these are programmable, so you can set various functions on there. We're not going to get into that now either, because obviously, again, we're just doing the assembly. Got the power cable all settled there. I might create a bracket later to hold this guy in place right there. Just worked out nicely with the length of that cable. I didn't have to change the length of that cable. And now that we've got everything in there like so, we've got a little space here to put that little distribution board back in there. So we'll go ahead and do that now. So now you can see that worked out quite nicely. These are the two connections for the landing gear, if you remember. And this is going to come up through to the top plate, and we'll have our flight controller on the top plate. And that's plenty of length there to plug that guy in. So I think we're good. I think we're really good. To be seen whether we need the aux at this point or not, maybe once we get the gimbal set up, but we'll go ahead and pull that out for now. So yeah, I think we're good here. What I'm going to do is I'm going to take some self-healing tape and wrap it around here just to keep that from making contact anywhere, and then maybe we'll tie wrap this guy somewhere here, just to keep him in place and keep him from bouncing around. Yeah, maybe right there. We'll go right there. We'll see. We'll see. Just like everything else, we're just making this up as we go. Yeah, maybe right here. Look at this. That looks like a nice spot right here. Yeah. All right. I think that's it right there. Yep. Okay. Yeah, if you guys haven't seen this before, so this is some silicone tape, and it's bonds to itself. So all you have to do is, and what's really cool is it's if you can look on the edge, it's thicker in the middle than on the edges. So if you're wrapping it around something, it actually keeps it from getting really thick as tape sometimes does when it's a uniform thickness all the way. So this one is really cool. Just peel it from the backing, and you get it peeled off of there, and you just stretch it a little bit, and then when you wrap it around, it will actually bond to itself. And so this is going to be really cool. We'll use this to, one, keep all the connectors from coming out of there, and two, all these little points at the back there from making contact with anything else. And then we'll get a double. I've cut it so that we have a double layer on the back here where the pins come out. This stuff is a little old. It's been sitting on the shelf, but looks like it's still bonding to itself pretty good, and it's pretty tough. So I can run my fingers across here, and the pins do not push through. Oh, look at that! Yep, there we go. So now all of those will be held in place nicely. We're going to use these holes here to tie wrap us down. You know what? I changed my mind. We're going to go right here with this, and then we'll secure these cables and everything. Once we do the testing, we're actually going to do the testing first, and then we'll secure those cables. But I'm thinking this guy is going to get tie wrapped right here, and then the cable can come up right through the hole. There's a same hole on the top plate. We'll go right through there. But yeah, next thing you're going to see, we're just gonna go ahead and put the top plate on temporarily so that we can mount all the parts that go on top and see how all that fits. All right, so what we're going to do here is, since we have the external back is providing 5 volts, we're going to, instead of going to the voltage in here, we're going to go right to the 5 volts. We're going to go around the 5 volt regulator that's on here, because the BEC that we have is can carry a higher load. So we're gonna spare this guy's 5 volt regulator. Normally what you would do is take the battery, the raw battery, and just go V in there. I think this can handle up to 34 volts if I'm not mistaken, but the amperage is not. What we're gonna do is we're just gonna go ahead and handle that off this board so we can protect this board a bit, and carry a little bit more amperage for the LEDs that we're going to be running by using this external back. And so we're just going to go right to the 5 volts here, and that'll go around the 5 volt regulator that we have. We're still going to get the 3 volts out because this stage is behind this stage. So in other words, 5 volts, not 5 volts, but higher than 5 volts in here, 5 volts here, and then that goes to the 3.3 volt regulator that comes out here. So we're still going to have the 3.3 volts. Whatever we're going to run off of that, whether it is real-time clock or whatever it is, we'll connect it here because that'll be a low current draw. But here we go. We're gonna hook this guy up right here. Later on, we're gonna tin these wires after we check out all the connections. So yeah. But before we actually power everything up, we're gonna pull this guy out of there, and we're gonna go with a meter, go across there, and make sure that all the voltages are correct and everything, so we don't burn anything up. Make sure that back is actually a 5 volt back, as I think it is. But here we go. Yeah, and we're just going to tin those wires so that the vibrations and everything won't just break off the strands, right? But again, we'll do that later after we get everything settled. All right, so we've got that set up, and now we're going to figure out what we're going to do for this guy. So we're going to try several different mounts. I do have some vibration dampers that we're going to screw into here. We're going to try those. I don't think we're going to need the vibration dampers, but we're going to fly it with and fly it without, and then we'll check out the flight plots of the vibration plots on the recording of the flight, and see what that vibration looks like with and without dampers. So that's one of the experiments we're going to try. Again, not in this video. Subsequent videos will cover that. All right, so we just pulled this off the 3D printer. I've already added some VHB on there, so it's just double-sided, very high bond double-sided tape. Got that on there, and we're going to try these vibration dampers. This is not exactly how they're used. I put threads in here. Usually you just put a nut on the other side of that, but we're just gonna thread these into there, and then we'll put it into this. We'll screw from the backside into this. We'll screw through the plate into that, and I already added some washers to take up the space. So this will be, just a little bit less than the thickness of the plate, so that we can cinch down on that. The important thing about these is that these metal inserts are just, so this rubber is just molded around these metal inserts. These are some old ones. The newer ones are better, or the hardware is anchored better into here. If I twist this a little bit too hard, it'll just twist everything off. Same with the screw. So we have to be careful with that. And like I said, we're just going to test to see what the vibration plot looks like. We're probably going to be running this without those dampers. So, yeah, but we're just going to do this as an experiment. We'll put them in first and then take them off later. But, so this is going to go just right onto here like this. And then the flight controller is going to get the VHB is going to hold the flight controller on there. Like I said, there's a lot of ways to do this. I just like making adapter plates and stuff. If you guys want access to this file, just let me know in the comments, and I'll go ahead and put it on the website so you guys can download it. And so yeah, I'm just gonna go ahead and get these screws on there and get this screwed on there, and then we'll power it up. Put the meter on these things. So let's see if we make sure we're getting the proper voltage everywhere before we plug in all of the electronics. And yeah, we're almost ready to configure this thing and take off. So here we go. Okay, now that we've got that secured in there, that's pretty quick, huh? I got those screws in there pretty quick. And yes, this is the base of a collapsible GPS. I'll show you guys how that works later. But what we're going to do now is we're going to check to make sure that we haven't blocked off any of the connections for the flight controller. So important things are, if we don't have telemetry available, we're going to need to use USB to connect to make the configurations and everything. We have the reset button there, so we need to keep that clear. We have a few connections on this side, and as you can see, that if we set the flight controller here, these connections will clear here. And I don't suspect that we'll be doing debug, but the FMU reset is also on that side, and everything is set back this way, and there's nothing right here where we're going to have the GPS, the base of the GPS mast or the GPS mast coming up. So that's good. So we're going to set this back so that we have a little bit of clearance space in the front there. But the other thing that we have that we want to keep in mind is once we get rid of these dampers, this is going to be sitting down really close to here. And if we're trying to remove this SD card, we have to be mindful that we may not have enough space back here. But it looks like this is the length of the micro SD card. So we should be just fine pulling it out of there. So I think that's a good spot. I think that's a good spot to land it. And the cool thing is, I know this is not at the center of any of this, and neither is the IMU probably on this flight controller. But all that can be, you can set up offsets in the software. I haven't looked at the latest Q ground control or any of that, but hey, we'll explore that together. One thing that I did with this is I made sure there was a nice thick bar going across there, and you can see in here that this is solid all the way across, and these are just here to hold that whole structure together. But this is solid and this is solid across, so that yeah, and it has we've got a stable platform there for the flight controller. So let's go ahead and peel the backing off this tape and position our flight controller now that we know that everything is clear. And I did try to make it so that it will be easy to align this flight controller. So all we have to do is get it exactly over that rectangle. So we gotta get this lined up nicely, because this stuff, once you get once you get things stuck to this VHB, it's pretty strong stuff. There we go. All right, here we go. It's kind of weird trying to do this looking through the camera, but we'll do the best we can here. And hopefully I get it lined up perfectly. All right, look at that. You can see that little wiggle it's got from being on those vibration dampers. I don't know. We'll see. I'm not feeling the vibration dampers right now, but again, this is going to be an experiment. We'll try it. All right, so as I said before, we're going to leave some things unplugged until we can check the voltages. And yeah, let me get the battery. All right, the sound you're hearing is the ESC, so all the ESCs are on. Got 5.05 volts. I like to do 5.2, so we may adjust that later because we're gonna have a voltage drop as soon as we plug this guy in, but we're okay to plug that guy in. And I've already checked the other voltages all the way around, so I won't bore you with that, but yeah, let's go ahead and plug these in. Let's go ahead and plug everything in, and next thing you should see is a bunch of lights blinking. All right, so chimes. All right, guys. So here we are. This is where we're going to stop this video. Obviously, the videos can get quite long if we don't cut it somewhere. So we're going to cut it here. So I've got everything put back together. We've got the battery in there. I'm going to show you a few things that we're going to change and a few things that didn't make it into this session. So I've left the GPS. So we've got the GPS mast on there. So it's a collapsible GPS mast. If you guys want to know where this one came from, let me know in the comments, and I'll put the link to that guy on there. But if you go on Amazon, you'll see them. Not that I shop on Amazon all the time, but you can find some there. So we've got that antenna, the antenna mast in. Everything is wired up, motors, and all of that. So the only thing that's missing is the GPS and the radio. And so the reason the radio is off, I actually have two radios. And this one is an FR Sky. It's a Tyrannus X7, and I have if you guys have watched the other video replacing screen and setting up a gimbal, I did that on the Radio Master 16 that we have. So I'm selecting this one for this build because well, this is a radio that I started flying with, so it's kind of nostalgic. But also I have this bracket, and since we're going to be doing stuff with the screen, I have a let me see if I see it. If I see it, I'll show it to you later. I do have a screen that's 5.8 gig that's gonna connect to the video hardware here. So we're gonna have two cameras. We're gonna have the one on the gimbal, obviously, and then we're gonna have an FPV camera for flying. So we're gonna have one for piloting and one to capture cinema with. But this bracket is really cool. It's a carbon fiber, and there's some aluminum hardware there. but it's a carbon fiber. I don't know. I don't even know if they make these anymore. This is a very old package. I've never opened it, and it's for attaching right here to the handle of the Tyrannus. So what we're gonna do is we're gonna have yet another video. I'm gonna show you how this one goes together for holding the little monitor that we're gonna have on here. And so the idea is that we're gonna have the monitor on here. We're gonna be able to switch between the cameras on there. We may use the phone at some point and use Q ground control. So I'll show you guys how to configure that and have 2 video feeds on there. But yeah, first we're gonna just put the monitor on there and grab the feed directly while we test, flying around, and then we'll add features as we go, like Q ground control and things like that, so we can do waypoint missions and all of that. But now, having said that, so there's gonna be a video where I attach the GPS and also attach the radio. And that may tie into setting everything up, setting the flight controller up using Q ground control. So we'll get into that again on another video. But I just wanted to show you, this is where we are. The battery's in there. There's a few modifications. I know I said I was going to fly the frame stock first and then do the modifications, but I was looking at the thing and I'm like, let's just go ahead, and it's not going to change that much. Let's just go ahead and do the modifications. So one of the things that I did was shorten this section of the landing gear, and then add these. These are actually from Tarot landing gear, as well as the folding. So we're going to have retractable landing gear, and this is our mechanism for doing that. This is from a Tarot, an off-the-shelf retractable landing gear setup. So I just did a mashup of the 2 landing gear. So this is obviously from the original landing gear from the frame. All of this, I shortened this tube by about 1 inch. I shortened this tube by 2 inches so that it wouldn't look so. It was massive. It looked like clown feet on this thing. But that's what I did. So I shortened this tube, and I shortened this tube to get us where we are now. And I made adapters again. As I mentioned before, if you would like those files, let me know in the comments. I'll add it to the website. These tubes have been shortened again, as I said before. I keep repeating these things. So the battery fits in there really nicely. We're going to have the gimbal. Once we're done testing this as is, we're going to, here's the gimbal that's going to go in there. So we're going to add the gimbal in there, and you can see how the camera and everything is going to hold in there. Let me see if I can get this with the background there. So you can see gimbal's going to be in there. The action camera will sit down in the gimbal. So that's going to be next in the series of videos. But yeah, this is how we wound up. So what I'm going to do is I'm going to open her up and put the props on there so you guys can see, get an idea of what she looks like now. Here we go. Move the camera over. And this is awesome. I like how the way. And you can see it's got a little play there. That's because of the gearbox. The gearbox for the it's got a little bit of play, but I've never had a problem. I've used this landing gear before. And it's it looks pretty cool when it retracts and it comes down. But I've never had any problems landing or taking off with this landing gear. So that play is it's normal, and it's not a problem when you're flying. So look at that, man. That is crispy when those go up. I love that. Nice. And just like that, we're up. And so go ahead and put the GPS mast up. So that's a pretty tight build. I'm pretty happy with that. That's a pretty tight build. At some point in the future, like I said, we might put some sides on there, some plastic sides that go into these little tabs. And there's little slots in the carbon fiber. We may take advantage of those and just 3D print ourselves some covers for that, just to keep the electronics, you know, from the dust from going in there. Let me put these props on here. I think this is this the one for this side? No, it's not. Oh, I was gonna. Oh yeah, there you go. So pretty cool. They're color coded. Silver, go on diagonal sides. You know, if you have a Phantom, you know how that one goes. So yeah, we'll do that. And yeah, goodness, this thing feels like yeah. So depending, I gotta do the calculations, but we may be able to, with these motors and this setup, go to a larger size prop. We'll see later. We'll see how it goes. But there it is. Okay. We'll cut the video there because I'll keep going. As always, I appreciate the time you spend with me. We're going to yeah, we're gonna have a lot of fun with this one. So stay tuned. We'll see you in the next video.